Welcome, everybody. My name is Victor Hollanda. I'm a software engineer here at CSCS. So today we're going to talk about the User Lab and how we get started at CSCS using your User Lab resources. So this presentation should last around 30 to 40 minutes, and we can, as Glenn said, you can ask questions anytime, point in time, and also you can also write on the chat if you are not willing to speak. So before we start, I just wanted to say a small disclaimer that all the information that you're seeing is a collection of that we have taken from either from the main CSCS website or our user portal, and also our user management portal. There are additional information that you can find in not so common places that we may not know. That's the CSCS GitHub public repository, and also some advertised products that we have. Also, we briefly touched them on these presentations. So the slides will be available and at some point in time, maybe today or tomorrow or next week. So as we have said, give us feedback. So it would be nice if you could also help us improve our documentation and presentations. So having said that, let's get into the presentation itself. So before we talk about how you get your resources, the most important thing is how you interact with us, right? If you have any problem, even before starting. So the way to start is by opening a support ticket, right? And the website is support.cscs.ch. So if you encounter any problem along the way, we're really happy to help you with your problems. So some people, because they don't know about this website, they tend to write us directly emails. It's much better if you do to the support tickets, because you actually get the visibility right. So sometimes you write to someone, it's not the right person. So then by opening support ticket, you get the right person jumping into the problem, and you get solved much faster. And but as normal, before you do that, just read the documentation. We have the main documentation is the user portal and our website. And again, please help us improve our documentation and website. The way you can access the User Lab, so considering that you have no problems and you can access it, is basically by having an account. And all the resources that you get are bound to projects. And these projects are mainly in the User Lab, 3 types of projects. One is called production projects, that's aiming for doing production scientific work, that you can do your proper science and investigations. And then there are other ones called development projects, where you aim to develop code, and you can do code development access to the system to check, if your code compiles in a Cray system, or if you can do CI on our side. So then you can play with different mechanisms that most of the people is not aware of. We also have preparatory projects, which allows, if you're a newcomer to CSCS, to port your code also, but also to acquire the technical data to apply for the production project. All the accounts of the users associated to a project. You cannot have an account that doesn't belong to a project. So you have to get a project first. And to apply for a project, you must be a principal investigator, as we call it. So the principal investigator for the User Lab is someone with either a PhD or a professor in a university. So you can get more information about the requirements on our allocation scheme on the website. The mechanism to get an account is basically by invitation. CSCS is like invitation only club, let's say. So then what you do, as a PI, you write your preparatory project, you send it to CSCS, and then someone from CSCS, a staff member, will invite you, create an account for you and invite you. After that moment, you can go into our webpage called account.cscs.ch, and then from that moment on, you can invite people to join your project. So you can have your team joining the project, and then from that moment on, they can access the resources. We do not open accounts, right, for the users themselves. It's the PI responsible for that. So if you as I said, you're required to apply for a preparatory project in order to get your account invited. After you get your preparatory project, you get your data, you can now apply for a project proposal. That's another mechanism. So in this case, you already have an account. So you basically just applying for a proposal project, and then the project proposal, and then what happens is the production project. And then in this case, it has a review process. And the review process is internal to CSCS, where we have the scientific community reviewing the scientific part of your application, and also we have the technical staff from CSCS reviewing if it's availability of your project to run in our sites. There's an exception to this rule that you may not have scientific review if it's that you apply for small projects which are below 36,000 node hours. In that case, you only get the review from the technical people from CSCS. So again, if you get approved, then we will send you the results saying, okay, you have got approved, and you can now again go to account.cscs, and then you can invite your team again, but now for the production project, not to the preparatory access anymore. So then you can have different teams, one for the preparatory project and another one to the production project. It's up to the PI to decide who will do the science at the end of the day, or who will be running or consuming the resources. So considering that you have already an account, that you started already, so there's some details that you have to be aware of. We allocate compute node hours on our side at CSCS for the user lab in quarters, natural quarters. So they start on April 1st, July 1st, October 1st, and January 1st. So these allocation schemes allows us to have a better fair of usage of the resources. So you need to make sure that you're using the resources that you have for the given quarter, because they do not go from one quarter to another one. Because if you do that, then if you don't use, you try to use a lot of resources with for instance, like your last quarter, and that you clog the system. So be sure to use your resources in a given quarter, because they won't move from one quarter to another. You can monitor the usage of your resources through the account.cs website. That's the same website where you can invite team members. And all the measurements we do for the user lab are done in compute node hours, right? So we do not allow people to share the nodes on our site on the user lab. In this case, then you have a full node allocation, so they can now do measurement in compute node hours. So what I try to describe with this picture here is basically what's written in the point. So if you start in a given time in the project, then you're going to have a 3 months allocation, that's a quarter. And then you have, if a projects are for 36,000 hours, node hours, small allocations for a year only. So then you're going to get 4 quarters, and then you need to use your 9,000 compute node hours on the quarter. Of course, you're going to come here and say, okay, Victor, wait a second. But if I want to use a bit more of my quota on a given quarter, can I do that? Yes. Send us a ticket, and then we can negotiate how you can use a bit more of your quarter. It depends on how everybody else is using their quarter. So, but can you write us and say, hey, can I get my quota moved? Unfortunately not, right? It's strict rule that we don't transfer between quarters your resources. So if you don't use it, you waste it. Considering that you already know this, and there are basically, how can I use those resources, right? I know that I have to use it, so I'm keen to use it. Let's get started. Well, there are 4 ways you can access CSCS. One is via SSH, that's what I'm going to talk about here. But there are 3 other ways. One is interactive supercomputing, so you can use Jupyter Lab, and then you can play with your notebooks and have different kernels running on the GPU and non-GPU nodes. It's a very can I say, a good way of prototyping the interactive computing. Another way you can also do that is through continuous integration. So you can get an allocation for your development projects, and you can keep using your resources when you make a pull request for your project, and then you can test your system, your code directly on our sites. And then the last way is by using a REST API, in our case Firecrest, that you can access and write code that you can monitor your usage on the site, on the system, using REST APIs. So as I said, I'm going to be focused only on the SSH part of these interactions, and because all of them have other dedicated presentations, so I will focus on the SSH. So you cannot SSH from your workstation directly to Pitstein, for instance. You always have to go through Ella. right? So this Ella is our gateway, some sort of a firewall, but you can proxy jump. So you can go from Ella and Pitstite in a single way. That's what we tell the users to make their workflow easier, but you have always to go through Ella. And many people, when they do that, they try to avoid using passphrases in the SSH, but we strongly advise you to use passphrases that are very strong, because Ella is a jump host, so you can get your keys compromised in the workstation. Everybody gonna be able to access your account at CSCS, and you may have to block it if anything wrong happens with that. So we strongly the users to still use passphrase or use passwords when you're connecting, even though you do SSH. The way to do a single step is doing this proxy jump that I have shown you, and I will show you two ways of. I'm going to show you one way of doing it, right? Using the strong passphrases. So there are two websites we have that describe this, but I'm going to give you the example in practice here. So what you have to do to get your passphrase and you get your proxy jump directly from your workstation to Pitstite is by first on your workstation generate your pair key, right? The SSH keys. We advise users to use the Eclipse curve type of keys that are slightly more secure. So then you should use ED 25519. That's what we advise. So then what you do, you basically copy your public part of your key into Ella, and then you enable the SSH agent on your workstation, right? And then from that moment on, you can add your key and then to your agent and then attempt to connect. There are two comments that I have to say here is that some people, they enable their agent on Ella themselves. So avoid enabling SSH agent on Ella. Just do SSH agent on your workstation only. Don't enable it on Ella, just on your workstation. And then if you finalize the configuration in your workstation, you just have to edit the config file on your SSH folder to allow you to easily type just SSH dint, which in this case, you enable the host Ella with your username, in this case, my CSCS username, and then you, on the dint configuration, you say I'm proxy jumping to the configuration that was done on Ella. Because we are using SSH agent, don't forget to do SSH agent forward, right? Forward agent, yes. After you finish this configuration on your workstation, on your laptop, nothing configured on Ella or on dint, then you can basically SSH to dint. There is a way that you can avoid doing this copy. So if you do not want to copy your public key to Ella itself, you can go to account.cscs.ch, go to your profile and add this public key there. So then in this case, your .ssh folder is basically empty. So if there's any problem at CSCS with a miscreant trying to taking control of Ella, then your keys are completely safe because not even the public key is accessible by the miscreant. What can you do by doing proxy jumping? Why you advertise to the users to do that? Well, because you can access directly. You can do SSH dint, right? You don't have to do SSH Ella and then SSH to dint. But also allows you to copy small files directly. So you can do SCP, in this case, a Gromax input file, directly the scratch folder on dint, and then it will go and be directly there. But this raises two questions. First question is basically, how do you copy larger files, right? I'm strictly speaking about small files. And what are the file systems mounted on the user lab, right? I'm talking about Scratch here. So what are these things? So I will mention about copying large files as a single line, which basically we advise, please use Globus Online, right? This allows you to do parallel copy. It's much faster. And we have dedicated services to have your data come from everywhere in the universe into our site. So you can use SCP, rsync, SFTP. Of course you can, but try avoid using these type of tools. Globus Online is much better, much faster for copying your data. So related to the file systems that are mounted on our user lab, we have some, right? We have the Scratch file systems, depending on where you end up. If you're doing to dint, you have the /scratch. From dint is a 8.8 petabyte Scratch, and if you go to ALPS, it's 8.7 petabyte Scratch file systems, two different file systems. But you also have the /users, which is your home folder, /project, which is basically the project that you can apply for getting these, and also store can also apply for. In general, store associated to people who have contracts at CSCS. If not, then if you apply for long-time storage, you can get a /project account or folder there. There are some things that has to be said here is that Scratch is the only one that is mounted fast, has a fast access speed on our side. So it means that it's the only adequate file system to run simulations. Please do not run simulations from home, and you cannot run simulations from project and store because they are read-only. So if you're trying to, initiate, for instance, your simulations and write the data directly to project, you can't because they are read-only, right? Because they are very slow in performance. So please use Scratch when running your simulations. And all of these file systems have quotas, but the quota of the Scratch file system only applies for submitting new jobs. If you run out of quota doing your simulation, it won't stop. It just continue running your simulation, but you won't be able to submit new jobs, right? So we don't stop you from doing your science. We're just asking you, hey, please revise the amount of files you have in your system because, it's not so nice to have so much files. It degrades performance. So you can read all of the information about each specific file system in our website. But I was just want to also make the last comment about the expiration policy. We remove files, not folders, from the Scratch file system every 30 days. So you should be copying files out of the Scratch. That's the reason why it's called Scratch, because it's not meant as your backup, it's not meant as your final destination to keep your files. Keep your files on /project or /home, even though it's a small location, or copy it out of Pitstein, but don't keep your files on Scratch because they will be removed. So the way to run simulations, because now you know how to connect, now you know that where you can copy your files, and then now how can I run my simulations? So basically, you need to do a fair share of the resources. We are using Slurm. So you can submit Slurm jobs, and then which is our workload manager. And then your job can be a script, a program, directly a binary, or interactive session. You can also log into the compute nodes through Slurm. So you can allocate your node, as I have said before, is completely fully allocated node. You don't share not in the memory, not the compute node, not the cores, or anything, or the GPU with any other user. It's your node that you can do your science. But for doing that at CSCS, we require some constraints, and one of them is that you explicitly select the projects, because some people, they do have multiple projects, and then there were some problems about using the quota for another project. So in order to solve the problem, we end up asking everybody to define their own project. Even though you may have only your own project, you're still asked to select the project when you're submitting your jobs. We understand that you may not be familiar with Slurm, or you may be familiar with Slurm, but you don't know exactly what options you can use. So we have written a Java interface, a small application on our web page and our user portal that allows you to select proper options for Slurm to run on Pitstein. So that's called the job script generator, and you can find the information on this script, on this link. So the way you can access the proper hardware to do your science is by basically three options that we have for the users. One of them is called the constraints. So it constrains the hardware, constrains which part of Pitstein you can run, because Pitstein is comprised of a GPU partition and a non-GPU partition. And then the way you can access the GPU is by using the option -- constraint when you're submitting the job. If you not care about the GPUs, or if your project is not allocated for the GPUs, you can use the multi-core partition. So part of the system, right? I'm saying partition, but not in the Slurm sense, in the sense of the cut of the system, right? A slice of the system. So there's a Slurm concept of partition, which are basically queues, and then we use that concept to define which workflow you are going to use. So we have the normal queue for running normal simulations, what's basically the normal usage of the system. But you also have the debug queue where you can debug your application, debug, a buggy input file or something, or buggy code. And also you can do pre and post analysis using the pre-post queue. So you can select which workflow you're going to do by the ---- partition option. There is some workflows require a bit more memory than we actually have. In PitSite, we have 64 gigabytes on the compute nodes. And if you require a bit more, like 120 gigabytes, we have a selected few number of nodes, and then you can access those nodes with ---- memory. That's the way you can access it. So as an example of the queues we have more queues, but this really applies only to User Lab, are those queues, and they have limits. So debug is for debugging, so you do interactive session for 30 minutes at in maximum 4 nodes. We have the long queue where you can run for more than 24 hours, but you have the limit of 5 long jobs. We have the normal queue where you have 24 hours. It's the basic one, where you can access up to 2,400 GPUs or 512 nodes on the multi-core part. We have the pre-post, which is also for analysis, a single node. In general, pre-post codes are for a single node or serial codes. And you have transfer queue, which allows you to do internal transfer between file systems on PitSite. These transfer queue is in general, so it's a dedicated set of nodes we have that have full bandwidth connection to all file systems, and they can read and write very fast to all of them. So you're transferring large files between file systems in our site. Please use the transfer queue to copy them. It's going to be much, much faster. And we do not charge compute node hours in transfer queue. That's very important to say, that when you submit your jobs to those long debug, normal, pre-post, you're being charged in your location. But transfer queues, you're never charged. You can transfer as much files from left and right in our site, and you're not going to be charged any compute node hour for that. So how do you submit your jobs? Basically, as I said, you can do scripts, and that's the type of script that you have on looks like in Slurm. So you start by saying that it's a bash script. It's a good practice to do that, because you're going to be writing bash here. And then you have this option called as batch, which allows you to pass option to Slurm. The two options that I have said that you are required is basically the account. So you have to give the project name. So you can say, I don't know, I have a project SK01, then you're going to get right here SK01. And you in your constraint, you're going to set what's the partition that you are using. The account doesn't have to be ---- account. You can use also -a, for instance. So all of these options, or most of the options on Slurm, have a smaller way of saying it. So instead of saying ---- constraint GPU, you can say -c GPU, right? So if you want also, for instance, to disable SMT multithreading, you can do hint multithreading, no multithreading, and you don't have the multithreading enabled on your compute node, and you can run without multithreading, for instance. In this particular case, I'm just highlighting also another aspect is that you're using multiple MPI ranks per node. In this case, if the application is MPI enabled, in tasks per node is equal to 12. So if you want all the ranks to access the GPU, you need to enable the CUDA MPS server. In this case, you do that by doing export create CUDA MPS equal 1, and then you can run your executable sharing the GPU. Of course, you take this script and you have to submit it, and the way to do that is by using the sbatch command from Slurm. But you can also modify. So imagine that you have written a job that goes for a specific queue, and you want to change the queue. Then you can just pass options on the command line, and it will overwrite what's written in your job script. In this case, I'm giving an example that's very silly because it's saying long, but it's asking for 1 day only. If you are doing long, you should be asking for more than 1 day, right? But then you can also change from going from CPU or GPU by doing the -c, and you can modify options when you're submitting it, right? Then if you don't want to do that, if you want to write this submission directly in your script, you can also do that. You can call srun directly. Instead of calling srun from your job script, you can call srun directly from the command line, and in that case, you just do, you can export environment variables that you want before, or along the line, and then you submit all the options in your application, and then you're ready to go. So these are basically more or less all the ways you can do that. Using SBatch or in SRun, and the same applies from SBatch to SLOC, where you can allocate resources and do the SRun iteratively. One thing that I want to highlight here is that if you're looking for a support from our side, it's way easier if you have a job script, because then it's easier for us to reason about the file that you can copy to your Scratch, and then you can go there, read, copy, and then try ourselves to see if there's any issue. Having submission by command line with SRun directly is not always the best way for us to help you, because it's a bit like more work. There's some good practice that you can do when you're submitting your jobs on Slurm. One of them is basically writing your email. So if you write your email when you are submitting, then you can get notifications from Slurm. So you can select multiple types of notifications. In general, tell the users, don't bother with them, just do all, and you're gonna get, when you started, when you finish it, and if it has canceled or has crashed for any reason, your job, you're gonna get notified for all cases, which is a good practice. And instead of going to the queue and checking, here's my location, here's my job starting or not, you can automate this process just by getting an email. Another way is that you should explicitly select the multi-threading that you are doing. So because Slurm versions can change, our configuration can change, and in some cases we can enable by default or disable by default. We are open to do that. So if you really want to guarantee that your job script survives along the time, then it's good that you directly define what's your multi-threading. That not only goes to the multi-threading, but it also goes for all the other options. But multi-threading is one of those that Slurm has changed 3 times already, if not mistaken, and then it has affected some users. So it's good that you do that. Another thing that I have already told you is that write self-contained scripts, right? So if you really need to define environment variables, load modules, do everything inside your script, because that allows you to reproduce better rerun your simulations, but also allows us to share with us if there's in case any problems. So then it makes everybody lives easier to reproduce and get faster support from us. Of course, there are good practices, but also there are bad practices, right? So some things that you should avoid when you're submitting jobs is doing loops and doing SRun SBatch. What happens in this case is 2 things. One of them is that you may have got the option of SBatch here to run multiple MPI ranks. So in this case, SRun will call SBatch as much times as you have asked for. So let's say if you have 5 nodes running a GPU partition and you ask for 12 tasks per node, then it's going to be 5 times 12, 60. So this job script will be submitted 60 times. So that's a bit problematic. Another problem about this is that this loop can be very fast. So basically, you are smashing the Slurm or the workload management to be replying to all your jobs that you're submitting very fast. So that has an impact on Slurm. And Slurm is a shared file system, so workload manager for shared resources. So then you shouldn't be breaking it. Right. Another way to avoid is by submitting multiple SRun commands inside the same job script. So there's a command called sact that you can actually visit the history of a given job. And in this case, this 1, 2, 3, 4, 5, 6, 7, 8, 9 job has submitted 25,233 SRun commands, and then that's not very good to do. So. And the way people do this is by writing these type of scripts here, where you can do SRun and do, put the end sign at the end, and then you just submit, and runs multiple tasks. Of course, this one is broken because you need to put wait all here. And we have seen users submitting, and then you break the system, and then you don't run anything. You just remove Slurm returns immediately. Another problem that we have is because some people do have run the simulations from the home folder, right? And I have said before, home is slow, don't do that. Get your things in Scratch and run from there. Another set of things that you should not be doing, but not on Slurm now, but also but they're associated to Slurm somehow, is things you should avoid in the login nodes. Some people, they do tend to do SQ and then watch SQ, so they get notified, or they see what's happening with their jobs. Well, instead of doing that, please use the email, right, option from Slurm, so you get notified by email. We have thousands of users in the system, so if you do a SQ and you grab your user, you basically going through all the users and then filtering you. But you could also directly just ask for your user, and it would be much faster, much better for Slurm. And then you just pass the option -u, and you get only the options for your user. Some people, when they're trying to compile the codes on the login nodes, they forget to pass the number of parallel threads they can use for the compilation. And there are many studies on the internet showing that most applications, they don't scale more than 8. So 6 is a good number for most applications. So you won't get much faster if you do make -j, and you get all the cores on the login node to compile your code. It will be slightly faster comparing if you do, -j6 or -j4, -j8. You're not getting that much speed up. So try to avoid unbounded make. Just do a fair share or fair usage of the login nodes. Some people, they also try to get some servers running the login nodes, and the servers basically in general, they are associated to their jobs, and then they want to run then to collect jobs and submit new jobs. So this is very bad to be running on our login nodes. In case you need to be running a specific service because your workflow or application requires that, contact us. We're going to find a solution for you. We're very happy to be working together with you to find, to optimize your use case. Another thing people try to do is run the pre-post analysis on the login nodes. Just don't do that, right? We have a queue for these. Just use the queue, so improve the usage. Having said that, I'd like to say thank you for your attention, and have fun.